VFD Vibes, your place for all things related to variable frequency drives. If you're interested in how to make things turn or manufacturing technology in general, then this is the place for you. I'm your host, Greg Weichman, and this is episode 5, Sturdy Startup. Today we're going to discuss selecting the proper input voltage and enclosure for your drive, and then go over some common mishaps for starting up your drive and tips to avoid them. To help discuss our topic today, I have a return guest, Tony Gabriel. Thanks for being here today, Tony.
Thanks for having me back, Greg.
I know you've been on once before, but for those that haven't heard the episode, can you tell us a little bit about your background and professional experience?
Sure. I've been working with VFDs for almost 25 years. I worked in a paper converting facility for a little over 10 years, an automation company for a couple years. I've been with Yaskawa now for about 12 years. I started in the technical support group where I remained for about 2.5 years. And then I transitioned into the building automation group where I produce quotes for our distributor network.
Awesome. Again, always appreciate having people with such a breadth of knowledge on the show. And since you are involved in quoting and a lot of that pre-project activity, can you tell us some of the important aspects and things to look for when you're selecting a drive?
Sure. Yeah, probably the most important would be addressing your voltage and amperage and enclosure type. Now, let's talk about voltage and amperage first. Generally, there's a 200 volt class and 400 volt class that our customers are going to be dealing with in the lower 48. Now, sometimes 208 and 240 volt or 230 volt are used as the same thing. So sometimes we'll get quote requests saying, hey, I have a 230 volt motor. I need a drive with bypass. Send me a quote. Now, I'll go back to the customer and I'll confirm with them, is it 208 volt three phase or is it actually 230, 240 volt three phase? Those are two very different power sources, even though they're in the 200 volt class drive. If it's a standalone drive, it doesn't matter. That cube drive will handle that variation in voltage, no problem there. The problem lies in packaged solutions that contain a control power transformer. Our control power transformers are not a multi-tap transformer, meaning they're designed for that single input voltage. So if we were to provide a 240 volt cabinet, and let's say they were applying 208 volt to it, the input voltage is proportional to the output voltage. If it's designed for 240 volt and we're putting 208 in, rather than that transformer sending out 120 volts to power other components like contactors or cooling fans or space heaters, whatever it might be lower, like 80 or 90 volts, and some of those components might not function properly. So it's important to get the proper voltage. So I would always clarify, is it 208 or 230, 240? And hopefully they come back and say, oh, it was 208. 208 is probably 95% of the time what you're going to see out there, but 240 does exist. And then in regards to amperage, you always want to make sure that your rated output current of the VFD exceeds the motor full load amps. Yaskawa drives and many other manufacturers are NEC rated, National Electric Code, for motor horsepower to amperage. What do I mean by that? A 10 horsepower motor, NEC amps, at 460 volt is generally 14 amps or less. And that's what our drives are rated to. A 10 horsepower VFD 460 volt would be rated for 14 amps output current. If you get into a certain situation, maybe a specialty application where it's a high pole count motor, high torque, it may have a higher amperage. It might have a 10 horsepower rating, but it might pull 15 or 16 amps full load. If that were the case, you'd want to upsize your drive.
Interesting. I knew that standalone drives could handle a voltage variation within their voltage class, but I never thought about how there are components in a packaged drive that could actually be affected based on the voltage within a class that you apply to that drive. So provided we understand our voltage and amperage, you mentioned enclosures. Are there different types of enclosures and what are they based on? Is it things like the environment? Is it temperatures? Or what information do we need?
Yeah, it could be all the above. Type 1, Type 12, Type 3 or Type 4X. It might sound familiar to some of the listeners out there. Let's go through and talk about the details of each one. Type 1 is designed for an indoor location, clean environment, conditioned air. We don't have rapid temperature changes. There's no condensation forming, no dripping water pipes or water spray, anything like that. If you had, let's say, an office location with conditioned air, a type 1 drive, you could put a type 1 drive on the wall in that condition, or a clean mechanical room, something along those lines. Now, type 12 is also designed for indoor, but it has a higher degree of protection. Think dirty mechanical room. Maybe you have some chilled water pipes running overhead that sweat from time to time because there's humidity changing. Maybe the maintenance personnel leave doors open because it's not air conditioned. In the summertime, it's hot in there. We have dripping pipes. Maybe it's a manufacturing facility. I worked in a paper converting facility. We made paper bags. And I remember installing type 1 drives there. Now, looking back and going through and cleaning those machines and cleaning out the drives from time to time, they were very dusty. A type 12 drive in that environment would have been a much better choice. If you're talking outdoors, type 3R is usually sufficient. Type 3R is going to include things like rain hoods, filtered ventilation, maybe a space heater as an option. And the space heater is not necessarily designed to keep the drive warm and toasty on a cold night. It's in there to keep condensation down, because if we're in an area where we have high humidity and rapid changing temperatures from morning to night, and this process happens over and over again, it's possible you could have condensation forming in the cabinet, kind of like a cold drink on a hot afternoon. And you don't want that on your VFD. So the space heater could turn on cool nights to try to keep condensation down. Now, type 4X is sometimes asked for, whether it be outdoors or indoors, maybe in a washdown environment, exposure to corrosive elements in a manufacturing facility, whatever the case might be. It's important to remember that type 4X made of stainless steel is usually very expensive. It's generally totally enclosed, maybe with air conditioning. It may have fan ventilation with hose-proof hoods, but it's a very expensive solution. And if it's outdoors, your better choice, if it's not exposed to a corrosive environment, maybe let's say along the ocean front where there's salt spray, type 3R is going to be your better choice for return on investment or dollars invested.
Yeah, a lot of where I've seen type 4X is food and beverage, where you have a lot of washdown situations. You also need equipment to stay clean. It can't house bacteria and dirt and things like that. When we say these type ratings, are these NEMA ratings, or how do they compare to NEMA ratings?
NEMA is a set of guidelines. And when I say type 1 or type 12, I'm referring to UL ratings, which are a more official guidelines, where NEMA is kind of recommendations. They both mean very similar things, but as a UL shop, we are going to provide a enclosure with a UL rating.
That makes sense. So we've got a drive picked out. Let's say we've purchased it. We've got it installed and wired up on the wall. What do we do next? Can we just flip the switch, turn on power, and our motor's going to turn?
Not a good idea to turn on power without first some preliminary checks just to make sure things are wired properly and the proper voltage is applied. Greg, during my time in tech support, you would probably be surprised how many times I got a call where we turned the power on and some smoke came out of the drive. And then we realized we put 460 volt to a 200 volt class drive. That happens, and it happens often, and it's not covered by warranty.
The magic smoke. I have seen that released plenty of times in my career.
And the problem with that is your customer is going to be upset with you, but your colleagues, if you're working on a maintenance crew or some kind of mechanical team with other guys, they're never going to let you live that down.
Yep. Nobody wants to be the butt of jokes for the rest of their career.
That's right. Yeah. So always verify that the power is correct. And how can you do that? Well, the drive has a nameplate on it. It's clearly indicated what you have coming in. Measure the input voltage before you turn on that switch. And then also verify that the wires are landed properly. This was another call in tech support that happened way too often, where we'd get the call, and this is sometimes how it went. And you might find this surprising. Get the call and they'd say, we have this drive, we powered it up, we programmed the drive. We've been trying to start it for maybe 20 minutes, getting all these erroneous faults, over voltage, overload, overcurrent. And then we realized we wired it backwards. The motor terminals are landed on the input side, and the input voltage is landed on the motor side. And sometimes, believe it or not, the drive will survive that condition. Sometimes it doesn't. Sometimes it lets out smoke. But if it survives, how did it power up and how did it work? Well, I'll talk about that real quick. On the output side of the drive, you have a set of output transistors, and built into those transistors are what we would call flyback diodes. That drive had power applied to the output side, and the power flowed through, or a current flowed through those flyback diodes, charged up the DC bus, powered up the keypad, everything appeared normal until you tried to start the drive. That check, verifying that your motor is wired properly, is usually a very simple check. If your motor's 10 feet away, follow the cable and follow it into the control or the box where it's wired or terminated, and look at the wiring. Is it landed on the output side? Generally, it's on the right side for the motor and the left side for the input power. A quick visual check might save you a big headache.
Yeah, I'm guessing not everybody gets so lucky that the drive survives that type of mistake. You mentioned left and right. Is there any common labeling to denote what should be the input versus the output side?
Good point. Yes. So the input side is going to be your L1, L2, L3, and your output side is going to be your T1, T2, and T3.
And that's pretty consistent across at least all of our Yaskawa drives.
Yeah,
correct?
Yaskawa drives, and I've seen it on other manufacturers. I think that is fairly common. I don't know if it's an industry standard, but that's what I've seen.
So we've got that correct now. What happens if we do all this and our motor's turning the wrong direction?
It's always important to, after you start up the drive, to check motor rotation. And in my experience, for whatever reason, it always seems like it's running backwards. You always got to make a change. And you can do that two ways with a VFD. You can change it digitally through a parameter, which will digitally swap two of the output legs, or you can swap two of the legs on the output side of the drive. Now, I always advocate doing it the old-fashioned way, where we're swapping two wires. The reason for that is, on certain model drives, if you were to go in and reinitialize the drive, which means putting it back to factory default, it may reset that parameter. And what happens if maybe your colleague reinitializes it to try to reprogram it, make it run faster, or change some aspects, and he doesn't even realize that now it's running backwards? He makes his changes, leaves, now the motor's running backwards. Chances are you're going to be there in the following days troubleshooting what's going on.
And worst case, since startup, maybe you weren't connected to the equipment, but now you are, you may have just damaged or broke equipment when you spun it the wrong way.
Very good point. Yep.
When you're going through this startup, a seasoned drive pro like yourself can probably fly through parameters and do a lot of setup off the top of your head, but are there any tools in the drive that help somebody get it programmed properly right out of the gate?
Sure. Yeah. Probably the most, or one of the most important aspects of a startup would be to auto-tune the motor. And what do we mean by that? What you can do is have the drive do this procedure, and there's two different types of auto-tuning. We have rotational and stationary. Rotational is exactly what it sounds like. We're going to spin that motor up, and the drive is going to take several different measurements, resistance of the windings, no load current, and some other higher level measurements that are going to help the drive to do things like speed search more effectively and make it as efficient as possible. We're going to use each amp of output current as efficiently as possible, so we're going to save some energy. The rotational tune, if you were to perform that, it's important to remember that the motor has to be unloaded. So if you had a new installation, before you put your drive belts on that pulley, do your rotational auto tune so we can do it unloaded, because the drive is measuring no load current. If the application is already loaded, let's say it's a multi-groove pulley, this is a 100 horsepower motor, and there's a lot of guarding in place, and maybe this is going to take a couple hours to take all this stuff apart, move the motor in, and drop your belts off the pulleys, you're probably better to do a stationary tune. In that case, it's a little simpler. There's a couple parameters you have to enter, such as motor horsepower and amperage. And then you do your auto tune. It's going to sit idle. It's not going to spin. And then you'd have a base tune in there, stationary tune, and you're good to go probably from that point on. One of the nice things about performing an auto tune is that in either the stationary or rotational tune, and this is on Yaskawa drives now, you have to enter your motor amps. Your motor amps are probably the most important parameter that you're going to set on a startup because that's how the drive protects the motor. It has no idea what it's connected to. You have to tell it what size motor is on the drive. So if you can't remember E201, that is the parameter that where we enter our motor amps, E echo 201, you can perform an auto tune and it's automatically populated in E201 when you enter your motor amps there.
Yeah, so some of the safety functionality of the drive gets automatically set with an auto tune. And when you say parameter E201, one of the cool things with Yaskawa drives is that parameter is the same no matter which drive family or which drive you're using. So you can commit that to memory right now and you'll never have to learn it again.
Good point. Yeah, that goes back to E7, Z1000, and now HV600 and all the other drives on the industrial side as well.
You brought up another point. Using the drive in itself does bring a lot of efficiencies, as we actually talked about in our last episode together. But doing the bare minimum doesn't necessarily make the drive run as efficient as it possibly could. So when we're trying to squeeze all of the power out of every amp that we're putting in there, auto tune is a great place to start. And that's a really important thing to do when we're all trying to save money, save the environment, reduce energy. At Yaskawa, we have teams of application engineers that know not just our drives inside and out, but the types of applications you're setting the drive up for. And they can often recommend that you tweak this parameter or change that parameter or do this setting to optimize the drive for your given application. And I think that's a really cool thing when we're trying to be as efficient as possible and economical and environmentally savvy as possible.
Yeah, I'd agree with that. Yeah.
So far, we've gone through our initial auto tune. What are some of the other common parameters that we tend to adjust at startup?
Yeah, when you're starting up a drive, you need to apply a run command and a speed reference. The drives are factory configured to look for a run command on S1 and SN. That probably sounds familiar if you've worked on a Yaskawa drive. That goes back several generations. S1 and SN, a maintain contact closure on the HVAC drives, will give you a forward run command, and some of the industrial drives as well. Now, the speed reference is sent externally from a signal generator of some sort, typically maybe a PLC controller. The drive is looking for a 0 to 10 volt DC signal or a 4 to 20 milliamp signal. Now, that's how they're configured from the factory. But sometimes we have serial communication protocols, let's say BACnet on the HVAC side, maybe Ethernet IP on the industrial side, where we're sending those commands over the network. And if that were the case, you would have to reconfigure the run command and a speed reference. And these parameters may sound familiar: B102, Baker 102 for your run command, and B101 for our speed reference.
Great. That gets us running at the speed that our process needs us to be at. Can you keep going with some other common parameters?
Sure. Yeah. So on a startup, and especially a fan or pump, and I probably tend to focus on HVAC applications because that's what I do in our group now for the last 9 years. And that was my primary focus in tech support as well. But one of the things I always had the techs change when I was doing a call in tech support, and often I'd get calls in tech support where the service tech would say, "Hey, I'm starting this drive up. What do I need to do?" And they wouldn't even know what they needed to run at, what speed. I'd ask them, okay, how are we sending a run command speed reference? We'd go through some of these basics. I'd get them up and running. Maybe I'd recommend a minimum speed. But one of the things I always had them do was change their accel and decel times, especially if it was a fan, from 30 seconds, which is our default setting, to something of 60 seconds or larger. If it was a 100 horsepower fan, I might have them turn it up to 90 seconds or something longer than that. And that would be C, like Charlie 101 for our accel, and C102 for our decel times.
So what would happen if somebody either fat fingered or didn't know better and say it tried to set that accel time to 1 second when it's physically impossible to spin that fan up to maybe 40 hertz in a 1 second time frame?
That does happen, and most likely you're going to have an OL2 fault, a drive overload fault. It's probably going to make some wonky noises too for that 1 second while it's trying to start and drawing a tremendous amount of current. And then the drive is going to fault out and basically disconnect output to the motor and sit there and fault. And then you have to troubleshoot it.
Yeah, that would make sense. And aside from needing to set accel, decel to be able to physically match the requirements of the application, I would imagine that a nice controlled acceleration, deceleration, it has to be good for the longevity of the equipment as well, right?
Sure. Yeah. So in the old days, let's say 20 years ago, when we're starting to cross the line, we're getting lights dimming. We're probably squealing belts. We're putting a lot of torque and force on bearings and housings, belt deflection. Rubber mounts are probably getting torqued. A whole bunch of stuff is happening. And then obnoxious noise coming out of the ductwork from 0 to 100%. Now with the VFD, we can ramp it up at a slow speed, and it's much easier on every aspect of the application.
Excellent. Now, let's say we're telling the drive to run, or at least we think we are. What are some things we should look at or do if our drive isn't running or operating the way we expect?
Good question. And during my time in tech support, this is probably what we dealt with half the time, a motor not starting on a VFD. And oftentimes, the service technician would call in and say, I installed this drive. It's not starting the motor. I think I need a new drive. And I'd say, okay, hold on. Let's step back.
I'd love to sell you one, but there's
Right.
probably something else going on.
Well, it was my job as a tech support engineer to convince you that the problem was outside the drive, which is 99.9% of the time the case. And I did that by confirming a run command and speed reference. And oftentimes I'd have the customer say, yeah, we're sending a run command on S1. We have 10 volts on A1. And they were telling me exactly what questions I was going to ask. So I kind of knew maybe they were a little above average as far as abilities with the drive. So I'd say, okay, very good. Let's make sure we have a run command. There's some monitors. U110 is a monitor that shows our digital input terminal status. And I'd have the service tech find U110 and ask, what do you see in there? It's all zeros. And U110 is a way to check the status. And if all the digital inputs are opened, it will be all zeros. Now, S1 is represented by the digit all the way to the right. And if that's a 1, I know that S1 and SN is closed. So the service tech might say, yeah, they're all zeros. And I'd say, okay, you don't have an active run command. He said, no, that's not the case. I have 9 other drives. They're all running. This is the last drive on the line. Controls is sending me a run command. We've been working on this for an hour. We're certain it's a bad drive. Okay, hold on. Do you have a jump wire? Yep. Let's put that jump wire in on S1 and SN. So I'd be sitting there on the phone waiting, maybe a few seconds, a minute. He'd say, oh, my motor just started. And U110 has a 1 all the way to the right. Yep, because you didn't have a run command on S1. Okay, I'll get with the controls guy. Maybe he had a broken wire. Maybe the controls wasn't sending the signal, but they thought they were. That's how we would confirm the run command. Now, on that same aspect, let's say he had a 1 digit all the way to the right. We confirmed a run command. Okay. And you said you're sending 10 volts on A1. Yep. And there's nothing there. Okay, let's look at U113. Now, there's 2 analog inputs on the HV600 drive, and many of the other drives, even in the industrial, may have 3 inputs. But there are monitors U113 and 14, which look at A1 and A2. So if he was sending 10 volts on A1, we'd look at U113, which shows the raw input value that A1 is seeing. And in this case, he's going to tell me it's 0. And I'm going to tell him, okay, there's no signal on A1. No, controls is sending me 10 volts. Those other 9 drives are running at 60 hertz, but we got nothing here. All right, let's take that jumper wire and put it from plus V to A1. Plus V is an onboard 10 volt signal that is going to send 10 volts to A1. and run it at 60 hertz. He'd put that jumper wire in. My motor just started, and U113 says 100%. Now I convinced him that the problem was outside of our drive, and he's got to figure out why his signal's not there.
Nice work. So it's important to remember that we need both a run command and a speed reference, because if we don't have either of those, then our motor is not going to turn. And what I learned that I think is cool is that we have those monitors, and through the keypad or through our Drive Wizard software, you can actually monitor the status of all our inputs and outputs, I would assume.
Correct. Yeah. So you could use Drive Wizard HVAC or Drive Wizard Industrial to connect your PC or your laptop to the drive, which is very nice to view on that versus the keypad. But you can also look in the keypad and see these monitors. Yeah, they're very handy, and I used them almost on a daily basis while I was in tech support.
Before we get any further into technical support, I'm going to call that a wrap for the day. In full transparency, Tony and I recorded close to an hour of content, and it seems the most fitting to break it into 2 episodes. Yes, that means you will hear from Tony for yet a 3rd time as we dive into some common faults and ways to troubleshoot them, as well as how to be prepared when calling into technical support. If you want to learn more about drive startups and programming, make sure to reach out to your Yaskawa regional drive specialist or local Yaskawa distributor. Please like or follow this podcast to stay informed when new episodes launch, and if we're doing a great job, please leave us a 5-star review. Thanks for joining us, and as always, we'll see you next time on VFD Vibes.